Okay, so let's start with this. Okay, so this is your more concept and stoichiometry 2 worksheet. So let's read the question. It says in a school lab. Sorry, let me admit people. Okay, they say in a school lab, a teacher prepared a solution of sodium carbonate. So I got solution of sodium carbonate, or just think of it as sodium carbonate solution. Okay, how did he prepare this solution? Is by dissolving 4.5 gram of sodium carbonate in 500 cm cube of distilled water. Okay, so this sodium carbonate is prepared by taking 4.50 grams dissolved in 150 cm, dissolved in 500 cm cube of water. Okay, so that's how they go about preparing this solution. Okay, then this solution, now they take 25 cm cube from this solution and then react it with 20.0 cm cube of 0.5 mole per dm cube of hydrochloric acid. So I know that this is a carbonate plus acid reaction. Then they have the equation over here. Okay, so that is the current context now. Okay, that's the current context of what's happening. So let's look at the first question. A part 1, calculate the number of moles of sodium carbonate dissolved in 500 cm cube. So actually, there's part A here, where I'm preparing the solution. Part B here, where I'm doing like sort of like the reaction. So in A part 1, actually, I'm referring to part A. Okay, so A part 1, actually, I'm referring to part A at the top there. So if I ask myself, if I look at this question, they ask me number of moles. So I'm sort of find the, now this N here represents number of moles, in case you see me write it. So they want me to find the number of moles of sodium carbonate. In my question, I know what's the mass of sodium carbonate used. Okay. So to convert mass to mole, I'll just need to divide by the MR. Okay. So I'm going to do the step now. So to find the moles of sodium carbonate, this is taken by using 4.50 grams divided by the MR, which is 2 times 23, because there's 2 sodium, plus 12, plus 3 times 16. Okay. So if you were to take 4.5 divided by this, it's actually 4.50 divided by 106. You should get 0.0425 mole. Okay. And this should remember all your final answer for this calculation, always in 3SF. Can? Okay, so the first one is actually a very simple one, Mark. It's just that when you see all this data here, you ask yourself, which one should I use, right? So when they ask the number of moles of sodium carbonate, you realize it will dissolve in 500 cm cube, you'll use part A here. Okay, you use the part A portion to calculate. Now, obviously, if A part 1 to A part 2 and you see the word hence, that means most probably you'll need to use your data over here. So they say calculate the concentration in mole per dm cube. So I know that I have the mole of sodium carbonate. They want me to find the concentration of sodium carbonate. So to do this, I'll need to divide by the volume, because mole divided by the volume will give me the concentration. So to do this, let's just do a simple math. The concentration of sodium carbonate, this is taken to be 0.0425 divided by the volume. In this case here, the volume you can see is 500 cm cube. So I'm going to divide it by 500. But you realize the units is in dm cube. So what should I do to the 500 is to divide it by 1,000. So it can become in dm cube. Okay? So if you were to do your math, we just multiply by 2. So this will be 0.0850 mole per dm cube. Now, some of you say, sure, actually, I think maybe we should use because you see down here is 3SF, right? But before that, the answer is actually 0.042453 mole. This is in 5SF. So some of you say, should I use the 0.425 or should I use the 0.042453? Now, in general, you should be using the 5SF one here, okay? But so in school, you should do this. Okay, in SGI, you should do this. But if you are in O levels, actually, they are fine with the using the answer from the previous part, which is 0.0425, to go and calculate our next part. Okay? But for now, let's just do the school way. So if you do the school way, it will be 0.042453 divided by 500 over 1,000. Then your answer here will actually be a 49 over here, 3SF. Okay? Okay, any questions so far? Thumbs up if all okay. Okay. You if not okay, you can always put a thumbs down that I know I must go through a bit more lah. Okay, so let's go on to the next part. So this this first few questions here is actually the part A lah. Okay, it's actually the part A. When I say part A, it's referring to this part A over here, where he's just trying to prepare the solution. Okay, he's just trying to prepare a solution. Now let's go on to part B here. They say determine the limiting reagent. Okay, this question is nice because they tell you to determine the limiting reagent. Now, normally the question wouldn't tell you one. Okay, then how do I know which one is the limiting reagent? How do I know I need to start calculating limiting reagent? Now, if you look at this here this question, you realize that the question gives me the number of moles of Na2CO3 because of whatever I have there. They also give me the number of moles HCl. So I have the number of moles of both reactant. Well, I get number of moles of both reactant. Now, if I have the number of moles of both reactant, then they ask me find the product, right? So the question is, should I use Na2CO3 as a starting point to calculate the product? Or should I use HCl as a starting point to calculate the product? You don't know, right? Okay, so actually the trick to knowing when is it limiting or excess reactant is when they give you the number of moles of both reactant, or they give you like some sort of starting point from both reactants, and you're unable to know which one to use as the starting point to find the product, right? Then you know it's a limiting reactant question. Okay, so let's determine the limiting reactant in this particular reagent, in this reaction. So I got two things. I got sodium carbonate. Okay, I got sodium carbonate, and I got HCl. Okay, in this particular question. So these are my two reactants. So to be able to know which is the limiting reactant, I must find the number of moles of each of them. So for sodium carbonate, actually you haven't found the number of moles because they use 25 cm cube, right? So let's find the number of moles in the, so now this one is part B, part B, okay, part B referring to this part B over here, part B, okay? So part B, so to find the number of moles of sodium carbonate, I will use what I have, which is the concentration, which I've calculated above, which is 0.0849. So I'm going to take the concentration of sodium carbonate multiplied by the volume of sodium carbonate. Okay, so concentration is 0.0849. Now, what's the volume of sodium carbonate used? So you read the whole question here, you realize this is the volume of sodium carbonate used. So it's actually 25 cm cube. So this one equals to 25. Now, please take note, you should divide by 1,000 because you need to convert it to dm cube. Or you need to convert it to dm cube. So if I were to do the math over here, you realize that the number of moles of sodium carbonate is actually 0.0021226 mole. Okay, that's the number of moles of sodium carbonate. Let me shift my HCl a bit further. Okay, now let's find the number of moles of HCl. So if you look back at your question again, volume of HCl is 20 cm cube. The concentration of HCl is 0.500 mole per dm cube. So I'm going to take once again the concentration of HCl times the volume of HCl used. In this case, it will be 0.500 multiplied by 20 over 1,000. So you're going to get 0.0100 mole. Okay. So normally people's issue is that they will normally write the number of zeros either too little or too much. So just be careful with the number of zeros in the question. Okay, so far like that. Now, take note, this is the current. Wait, sorry. So if I look at this, right, what I'm going to write here now, so it's a bit different from what your teachers will write. So just ignore the current mole ratio. That means in terms of how many moles each of them have, right? So I know that the mole of Na2CO3 to the number of moles of HCl, it is 0.0021226 is to 0.0100. So this is the current number of moles in the solution, in the reacting solution. Right? Current number. So this number is too weird to do anything. Right? So what I'm going to do is I am going to make one of the number become one. So to make one number become one, I'm going to divide it by the smallest number. So what's the smaller number, which is actually divided by 0.0021226 lah. Okay? So when I divide it by this number, I am going to get 1 is to, okay, and I need to press my calculator. Please give me a moment. 0.01 divided by 0.0021226. So this will be 4.7. Okay, so currently in the solution, for every 1 mole of sodium carbonate, there's 4.7 mole of HCl. This is in the current situation, in the current solution that you have mixed together. Any question? Okay, if no question, can I just have everybody thumbs up? So can I? Okay, now this is the current situation. Now, but in terms of the reaction, so in terms of equation, mole ratio, so by equation, so I'm going to look at the equation mole ratio. So I'm going to compare my number of moles of Na2CO3 is to number of moles of HCl from the equation. Okay, from the equation. So if I look at the equation here, it is 1 Na2CO3 react with 2 HCl. So based on chemistry reaction, I know that 1 Na2CO3 will react with 2 HCl. Okay, this equation mole ratio is like the law. Okay, it's like the law. So 1 Na2CO3 is supposed to react with 2 HCl. Now let's compare. If I compare the current situation and compare by law. So if I look at the current situation, you realize that shit, the HCl not so many. I thought I only need 2, only how come got 4.7? So what does it tell you about HCl? It tells you that in the current situation, HCl is in excess. Okay, it tells you that the current situation, HCl is in excess. And take note, if one of the reactant is in excess, the other reactant will be considered limiting. It always comes as a pair. You won't have excess without limiting one. You won't have limiting without excess one. So it always comes as a pair. Okay? So based on this, what you can now then conclude is that since there is excess HCl, therefore Na2CO3 is the limiting reactant. Okay? So you can see here, it is by logic. When you compare the current situation, which is the current mole ratio, you compare to the law, which is the equation mole ratio, you will realize that the current situation, there's excess HCl. Therefore, Na2CO3 must be the limiting reactant. Okay? Any questions so far? I saw someone ask question just now. Then okay lah, now you know lah, you must use the mole ratio given in the reaction. It's just that you must compare the current situation and compare to the equation mole ratio. Then you can know which is excess, which is limiting. Okay? Anyone got any question? Thumbs up if all okay.
Oh wait,
Okay.
Mr. Eugene. So like,
Yeah.
do we need to use the current mole ratio or like not necessarily?
If you don't use the current mole ratio, then how you find which is limiting excess? Because limiting excess is based on the current situation. If you use the
Oh,
equation mole ratio, right, it will forever be perfect one.
okay.
Yeah, can? Okay, any other questions? Anybody? Okay. So what's next? So the question really, in terms of what's next, is that why the crap would you want to find the limiting and excess reactant? Why would you want to find it? Because you realize volume of CO2 gas produced is a product, right? Okay. Product calculation is based on limiting reactant. Okay. So you will always use your limiting reactant to calculate the amount of products formed. You cannot use excess because excess is way too much. Actually, does it mean that if it is an excess reactant, it means not all the reactant will react, right? Because that's extra. But if I calculate based on the excess, it means I'm using the extra for calculation. It means I will have more products than expected. Okay, so that's why all your calculations is always based on the limiting reactant. Therefore, finding the limiting reactant is important so that you can find the more products formed. Okay, so enough of nagging already. Now let's go and do this. So I want to find the volume of carbon dioxide formed. Okay, to find the volume of carbon dioxide, I will need the mole of carbon dioxide. To find the mole of carbon dioxide, I will need the mole of the limiting reactant, which is the mole of Na2CO3, which I have calculated. Okay, mole of is this one, right? Over here. Okay, this is the mole of Na2CO3. Okay, so now let's look at the whole thing. So, oh, sorry, so if I look at this here, the arrow actually represents the working or the steps. So to find Na2CO3 number of moles to number of moles of carbon dioxide, I must multiply by the mole ratio. Okay, so in this case, the mole ratio, let's look at the equation. It will be 1:1. Okay, 1:1. So I know that this will be times 1/1. Next, to find the volume of carbon dioxide, because it's a volume of gas, I know I need to multiply by 24 dm cube. Okay, so I'm gonna show you how to skip step. I'm gonna do one shot to find the volume of carbon dioxide because my working is this already. I know what's the whole thing to do together. So to find the volume of carbon dioxide, actually what I'm gonna do is take the number of moles of sodium carbonate times 1/1 times 24, which will then be 0.0021226 times 1/1 times 24. Okay, so if you were to do this, your answer will be 0.0509 dm cube in 3SF. Okay, now some say, sure, if I combine everything like that, will I lose marks or not? How is my 2 marks allocated? Okay, how is this 2 marks allocated? This 2 marks allocation, actually 1 mark goes into finding the mole. Okay, so 1 mole, sorry. No, 1 more. 1 mark is goes into finding the number of moles of carbon dioxide. 1 mark goes into finding the volume of carbon dioxide. Okay, to find, you see, the 1 mark to the number of moles of carbon dioxide, this one, I need an evaluated answer. So if I look at my working there, if let's say I press calculator wrongly, right, my final answer is 0.10. So my final answer is wrong, right? Then I say, sure. Actually, I find number of moles of and a number of moles of CO2. Where did I find it? I say, sure, this is to find the number of moles of CO2, ma. Can give me marks or not? The teacher cannot give you marks because why? You didn't evaluate the answer. So this is the problem when you combine every single thing to one working. Okay, so you must be careful. Doing this looks like it's very fast, it's a shortcut. But when let's say you press calculator wrongly and your final answer is wrong, you are not gonna get the working marks in the middle. Okay, so just be careful if you want to do what I did here. Can? Thumbs up if all okay. Yeah. Okay. So we have gone through this part already. I think most of you understand the way how I do my mole calculation working with the arrow and everything already. Okay, so let's go on. Now, they say the teacher then heated the resulting solution to dryness to obtain 0.200 grams of sodium chloride. Then you ask, hey, where is sodium chloride? Oh, sodium chloride is here. Okay, sodium chloride is here. So they say they got how many moles of sodium chloride? They got the mass of sodium chloride obtained is here. Then what's the issue here? To find percentage U, once they say this, you know that I need to find actual U divided by theoretical U times 100. Okay, then you must ask yourself, sure, then this 0.200 gram of sodium chloride, is it actual or theoretical? Ask yourself, what's the difference between actual and theoretical? Theoretical is calculated one. Actual is experimentally obtained one. Okay, I repeat out. Actual U is experimentally obtained. Means you obtain from the experiment. Theoretical U is actually the calculated one. So if I look at this particular question here, they say heated to dryness and I obtain 0.20 gram of sodium chloride. So this one is the actual U because it is obtained from the experiment. Then to find the percentage, you realize, sure, I got actual U. How to find percentage? I need a theoretical U, right? So actually they are trying to tell you, calculate the mass of sodium chloride formed, right? Calculate a mass of sodium chloride that should be formed. Okay, so then this will actually be your theoretical U, which then you can be inserting it into the formula to find your percentage U. Okay, so to calculate the mass of sodium chloride, I will need definitely the moles of sodium chloride. So realize every single thing you always want to find the mass, the volume, whatsoever. Basis, because the chapter is called mole, you must always go and find the mole one. Cannot run on. So I need the mole of sodium chloride. To find the mole of sodium chloride, I need to calculate from the mole of something. So what's the mole of something that I should use? Remember, you got two reactants, right? You got sodium carbonate, you got HCl. Should I use sodium carbonate or should I use HCl? The answer is use sodium carbonate. Because why? It is a limiting reactant. Take note, all products should be calculated from the limiting reactant. Okay? That's why this whole limiting reactant stuff is like so important. Because you cannot just anyhow use, must always start from the limiting reactant to calculate the rest of the products. So this one will be number of moles of Na2CO3. Okay, so looking at this whole thing here, let's do the steps. So number of moles, I must times mole ratio. What's the mole ratio here? Go back to my equation. It is 2:1. Okay, so to get to sodium chloride to this, I'm going to multiply 2/1. Next, to find the number of moles to mass, I'm just going to multiply by the MR. So let's do it all in one step. Let's find the mass of NaCl. This is to take the number of moles of sodium carbonate, which is 0.0021226, times 2/1, which is the mole ratio, times the MR, which is 23, plus 35.5. Okay? So you will take all this and lump them up all together. The theoretical U will be 0.248344 grams. Okay? Now, at this point, I will ask myself, does this number looks correct? Why? Because take note, percentage yield will never be more than 100%. Never. So if it's never more than 100%, means the theoretical yield must always be more than the actual yield. So take note, theoretical must always be more than the actual yield. Okay, so this is something that you, if you are aware, you can always check to see whether you are doing it correctly. In this case, I was 0.200, I was 0.48344. I know that, okay, I'm safe. So to find the percentage yield, this will be 0.200 over 0.248344 times 100. So if you were to do your math, this will be 80.5% 3SF. Okay? Any questions so far for this one? Thumbs up if all okay. Not all sleeping out, I haven't sleep, yeah. Okay, can. Okay. Let me now move on to the next question. I'm gonna now move a bit faster already. I think more or less you all get my style already. Okay, so let's go on. Okay, next one. Okay, substance X is impure copper 2 oxide. So substance X is impure copper 2 oxide. Once you see the word impure, you know that's it. Most probably got some percentage purity or percentage yield crap that's gonna come up. Okay. In order to determine the percentage purity of substance X, the following procedure was carried out. So what they did was they got 30.0 cm cube of 1.00 mole of HCl. So this is the volume of HCl. This is the concentration of HCl. Okay, was added to 0.65 grams of the substance X. So this mass of X, take note, X is impure. So is copper 2 oxide? Answer is no. It is impure copper 2 oxide. So I cannot say 0.650 grams is copper 2 oxide. No. This copper 2 oxide plus other things. And because it is impure, I cannot use it to calculate product form. Okay, because impure, I cannot use it to calculate product form. Okay, because the other substances, and hence the whole 0.650 grams of that prep is not going to be copper 2 oxide, which then whatever I calculate is going to be wrong from there. Okay, am I making sense here? Thumbs up if all okay, understand what I'm saying. Thumbs up. Okay, good. Okay, so now take note. When you read this further on, they said this: the excess hydrochloric acid that did not react with substance X, which tells you that in this situation, hydrochloric acid is in excess. This guy here is emitting up. Okay. Now, so that's reaction one between my sample X and my HCl. Reaction one. There is a reaction two happening. What is reaction two? They say the excess hydrochloric acid, whatever that did not react, whatever HCl that did not react. So I got reaction two over here. Whatever leftover HCl that did not react, they then titrate it with 20 cm cube of 1.00 mole of Vn cube of sodium hydroxide. So this is the volume of sodium hydroxide. This is the concentration of sodium hydroxide. Okay? So the reaction two is actually the leftover HCl plus sodium hydroxide. This is reaction two. Okay? Then they say after I do all this, the amount of copper 2 oxide which reacted was then calculated and subsequently used to determine percentage purity of substance X. Okay, fine. Now, let's look at this question. It says, state one assumption that was made by the student. The assumption will definitely have to do with the impurity. Now, what you realize here is that when I add hydrochloric acid to substance X, one assumption is that the only thing that reacts with hydrochloric acid is actually substance X. They say, yeah, duh. But then my question to you is there are impurities, right? If the impurities react with substance X, that means the amount of HCl left over will actually be lesser. And hence it will affect my subsequent answer in reaction 2. So therefore, one assumption that I must make in this whole calculation, and I hope that it is a correct assumption in terms of in real life, okay, when I'm doing an experiment, is that the only, only copper oxide reacted with the HCl, which means that the impurities in sample X did not react with HCl. Okay, because if they react, the amount of HCl left over will be lesser, the amount of sodium hydroxide used will be lesser, then when I do my calculation in terms of the copper 2 oxide, actually it will be different value. Okay? Okay, so now let's go on to this. They ask you calculate the number of moles of excess dilute hydrochloric acid that react with sodium hydroxide. Now, most of you are very stunned by this stupid word excess. This excess, just think of it as is the leftover from reaction 1, which is used to react in reaction 2. Okay? Thumbs up if all okay, understand what I'm saying? Don't understand, can put thumbs down, I'll say again. I'll still go and find the thumbs up. Go and find. Okay, can good. Okay. Okay, come. So let's go on to this. So what I'm going to do is I want to find the number of moles of HCl. That's the leftover, right? To find this, I need the number of moles of NaOH because they said that reactor is sodium hydroxide. To find the number of moles of NaOH, I will do from the concentration of NaOH. Okay, so these are my steps here. So what I'm going to do, concentration to mole, I will need to times the volume of NaOH. After that, number of moles of NaOH to HCl, I need to times the mole ratio. Then the question is, sure, what is the mole ratio? Let's write the equation. So sodium hydroxide plus HCl, it will give me NaCl plus H2O. So this is balance. If you look at the whole thing, it's balance. So I know mole ratio is 1:1. So actually times 1/1. Okay. So let's do it all in one step again. Number of moles of HCl is equals to what's the concentration? 1.00 times 20/1000 because you convert to dm cube multiplied by 1/1. So if you have to do everything together, you'll get 0.0200 more. Right? Can? So this is now moles of HCl, bracket 3SF. Okay? Next, calculate the number of moles of hydrochloric acid that reacted with substance X. So question is, if you want to find the number of moles that react with substance X, I must take total minus the leftover, or I should say initial total of HCl minus the leftover number of moles of HCl. Then I can find the number, I can find the reacted with X amount, right? So let's see, do I have the total amount at the start? Yes, I have. Can you see this 30 and this 1? This is the initial amount of HCl that was added, which is the initial total. So let's find the initial total number of moles of HCl. Okay, initial number of moles of HCl, which is 1.00 multiplied by 30 over 1000, because must convert to dm cube. So if you were to do that, you're gonna get 0.0300 more. Okay, that's the initial. Then I want to find how much reacted with X, right? So to find the amount that's reacted with X, number of moles of HCl reacted with X, this will be taking the initial minus the leftover, which is 0.20. So this is the leftover, right? HCl. So then you're gonna get 0.0100 more. Okay, so this is the part 2 already. Bracket 3SF. Any questions at this point? Part 2? All okay? Thumbs up if all okay. Okay, can. Now, so with this, I must tell you this, this kind of reaction will occur very frequently in JC. So you better be very used to this whole 2 times reaction for experiments and then do, they call this a back titration. Okay, they call this a back titration. Okay, they call this a back titration. So it's quite common in JCs or even in poly when I do research as well, or uni and do research. So just got to get used to this stuff. Okay, so although you're a bit stunned now, don't know what's happening, please go and catch up on this. Okay. C part 1 is not really mole, it's just chemical formula. So copper 2 oxide react with hydrochloric acid, HCl. Okay, they want state symbols. So this will be solid. This will be aqueous. What I'm going to get is copper chloride, aqueous, plus water because it's a base plus acid reaction. So I'm going to get salt plus water. Okay, so this is it. I'll need to balance. So I put 2 here and I'm done. Okay, so 1 mark for the equation, 1 mark for the state symbol. Can? Okay, so 2 marks, easy marks. So the kind, your chemical formula is okay. Actually, this will be no problem for many of you. Okay, let's go on to the next question. Okay, next one, calculate the percentage purity of substance X. Okay, so I need to find percentage purity of X. To find percentage purity, I'll need to find the amount of CuO in X divided by, okay, sorry, shouldn't use the word amount, let's be more precise. I need the mass of CuO in X. I need the mass of X, which is the impure sample, times 100. So you realize you already got a mass of X. They say the mass of X is 0.650. So I know that this guy here is a 0.650. So I need to find the mass of CuO in X. I need to find the mass of CuO. Okay? So what I know is 0.0100 mole of HCl. So this guy, 0.0100 mole of HCl reacted with CuO. So which means from the number of moles of HCl, I can find the mass of CuO. To do so, I must find the number of moles of CuO, and I find the mass of CuO. Can? So to do this, multiply by the mole ratio. After that, you multiply by the MR. So this one mole ratio is times 1/2. MR will be 64 plus 32, okay, which is 96. So let's do the working now. So to find the mass of CuO, it will be 0.0100 multiplied by half multiplied by 96. Sorry, not 96. Yeah, it's my math wrong. Oh, sorry, my math wrong. This CuO, this is not CuO2. O is 16, so it's actually 64 plus 16. My bad. So this one here should be 80. Okay, so this is the working. Do your math. This will give me 0.400 grams. Now, take note. At this point, I can also check my answer. Why? Percentage purity will never be more than 100%. Never. Which means that the mass of CuO must always be less than the mass of the impure sample. So in this case, I will double check. 0.400, 0.650, I know I'm safe because the mass of CuO calculated is less than the mass of the impure sample. Okay, which means that if CuO is 0.400, there must be 0.250 grams of impurity. Okay, so anyway, let's do this now. Percentage purity will be 0.400 grams divided by 0.650 grams times 100. You're going to get 61.5%. Yes. Okay. Okay. Any questions so far? Thumbs up if all okay. More questions can unmute and ask. So anyone got any questions can unmute and ask. Otherwise, giving another 5 more seconds. No one got any questions. I'll move on.
For the what's that? For the limiting reagent, is it?
Yeah. Okay.
Is for the working, do we have to write down like everything you wrote down there?
Which one? This one?
It's a bit higher up.
This one.
Yeah.
Okay, so if they never ask you find the limiting reactant, right? Don't need to do this kind of thing. So it's only when you need to determine the limiting reactants, know which one it is, then you need to do this kind of stuff. Okay, but if you already know which is the limiting reactant, you don't need to do all this working. You just use the limiting reactant as your basis of calculation. Can?
Okay, thank you.
Okay. Okay, now next one. This one exciting. 4 marks, one shot. So let's do this. Okay. This kind of question, I must tell you, is the weakness for many of our SGI boys because our SGI boys don't like to read the question. You all just like to straight away jump and start to. So please always read first. Okay, so carbon monoxide is a toxic gas formed by incomplete combustion of fuels. Okay, toxic gas, incomplete combustion of fuels. Carbon monoxide combines irreversibly with hemoglobin in red blood cells, preventing oxygen from being transported around the body, resulting in breathing difficulties and subsequently death. Okay, so this guy dangerous, danger. Okay, now they say 50 grams of hexane fuels, C6H14, is burned in 30 dm cube of oxygen gas, which I know is O2, according to the equation below. So they very nice write the equation balance for you. They ask you, what is the volume of carbon monoxide formed? So you realize, sure, they give me hexane, which is reactant, right? Reactant 1. They give me oxygen, which is reactant 2. How to find the amount, how to find the volume of carbon dioxide formed? Which reactant should I use? So you realize once you say, sure, which reactant should I use? At this point, we need to find out what is the limiting reactant. Okay? So whenever you do not know which reactant to start from, that means you know that's it already. You need to find out which is the limiting reactant. Okay, so we're going to do what we did on the top there. We're going to look at the two reactants, which is C6H14. The other one we're going to look at is O2. So let's start. Let's find the moles of C6H14. This is equivalent to 50 grams. Okay, 50 grams divided by the MR, which is 6 times 12 plus 14 times 1. Okay, so I realize the O2 there, very sorting. Let me remove it. Very irritating. Okay, so O2 I will shift it further down because I must remember to calculate later. So 50 divided by this number, this will be 50.0 divided by 86. What you're going to get is 0.58140. Okay, that's the number of moles of C6H14. Now let's go and find the number of moles of O2. Okay, number of moles of O2. This is the volume of gas. So I know that to find number of moles is just taking 30 divided by 24 dm cubed. So this will mean that I got 1.25 mole. Okay, 1.25 mole. Okay, so let's find the mole. Let's find the current mole ratio. Right, current mole ratio. I'm gonna take C6H14 is to O2. So currently there's 0.58140 mole of C6H14. There's 1.25 mole of O2. Remember, you cannot use this number to go and see on. So let's convert it to 1. So I'm going to take this divided by the smaller number. So divide by the smallest number is just to make sure that you can get the 1 over there. Okay, so this will be, if you divide by itself, is 1. Then I'm going to take 1.25 divided by 0.58140. This will be is to 2.149. This is the current situation, the current mole ratio. So to know whether it's limiting or excess, I need to compare. Compare it with what is the equation mole ratio. So equation mole ratio for C6H14 is to O2. The mole ratio is 2 is to 13. They say, sure, 1 is to 2.149, 2 is to 13. Actually, you realize there's no base for comparison. So I'll make sure that there is a common thing to compare. So what I realized is that I'm going to make the C6H14 to become 2 is to something. Okay, so the current mole ratio converted to 2 is to something. So I know that this one must times 2. So which means 2.149 actually is 2.1. Oh, sorry, it's 2. If I round up properly, sorry, it's not 2.149, it's actually 2.15. So if I take 2.15 times 2, this will be 4.30. So now if you compare, right, you realize C6H14, C6H14 both is base 2. So I just compare O2. So currently I got 4.30 mole of O2 reacting with 2 moles of C6H14. The equation tell me I need 13 moles of O2 to react with 2 moles of C6H14. What does it tell you about the current amount of O2? This guy here is not enough. If not enough means that it must be the limiting reactant. Okay? So to determine the limiting reactant is actually a very logical thing. You just look at it, it will make sense on. Okay? It will make sense on. Okay? So if this is the limiting reactant, then okay. Then I know that I will use O2. So I'm going to use a number of moles of O2 for my subsequent calculation. Okay? This is just for you all to take note. Once you find limiting reactant, this will be the portion that you must remember. Okay, so once I know the number of moles of O2, once I know O2 is my limiting reactant, I will use O2 to do my calculations. They want number of moles of carbon dioxide. Number of moles of carbon monoxide. It means that I must go and find the number of moles of my limiting reactant, which is O2. Sorry, do wrong. Yeah. I want to find the volume of CO, which means I need to find the number of moles of CO. To find number of moles of CO, I must start from the number of moles of my limiting reactant, which is O2. Okay? So, to find mole to mole, I must multiply by the mole ratio. Now, this mole ratio is a cheeky one. Why I say cheeky? Because you realize the number is 13 and 12. Okay? So this mole ratio here that I'm going to multiply will be 12 over 13. Just take note, it's always what you want to find on top, what you want to start from at the bottom. Okay, that's why it's 12, which is the product I'm going to get. Starting point, which is O2, 13. So it's 12 over 13. To find the volume of CO, I'm going to multiply by 24 dm cube. Okay, so this will be my steps. So let's find the volume of CO. This will be number of moles of O2 is 1.25 times 12 over 13. Okay, after that, times 24. So if you were to do your math, this will give me 27.7 dm cube, which is my final answer. So you realize why is it 4 marks? Now you know lah, because you must find the mole of each of them initially, determine the limiting reactant, then finally find the volume of CO produced. Okay, so this is the entire working for these 4 marks. Any questions so far? Thumbs up if you're okay. Got question, unmute and ask. All sleeping, yeah. Thumbs up if okay. All sleeping, right? All sleeping, I want to go and sleep, I tell you. I am so tired. Okay, let's go. Okay. Part B is not a mole calculation question. It is a acid-based question. So what type of oxide is carbon monoxide? The answer is it's a neutral oxide. Okay. If you don't know why it's a neutral oxide, please go and revise your acid and base. Okay, next one, let's go on. Carbon monoxide reacts with nitrogen monoxide according to equation. So I got an equation here. They ask you to calculate the volume of nitrogen formed. So I want to find the volume of nitrogen formed. Volume of N2 formed when 80 dm cube of carbon monoxide reacts with 60 dm cube of nitrogen monoxide. It's like, why is this happening again? I must what? They give me the volume of CO, they give me the volume of NO, which means they give me reactant 1, reactant 2 volume again. I need to go and do that whole calculation. Yes, you are right, but no, you're also wrong. Why? Now, this is the interesting thing about this particular question. Okay, you don't need to calculate the number of moles of each of the reactant if both reactants are gases. Now, take note, for this particular question, you can only do this method only when both reactants are gas. Okay, when both reactants are gas, you can compare using what we call a volume ratio. Okay, so the mole ratio will be equals to volume ratio because why? Mole times 24 equals to the volume, right? So you realize that times 24 divided by 24 actually gives you the same ratio. Okay, it gives you the same comparison, gives you the same ratio. So now what I'm going to do, I'm going to show you a shortcut. So in this case here, I'm going to compare volume of CO to volume of NO. This is 80 is to 60. 80 to 60, yeah? So let's bring it down to the lowest ratio. So I know that 60, 60 so obviously 1. Uh, 80 divided by 60, I'll get 1.33. Right, 1.3. So I know that in terms of volume ratio, it is CO to NO is a 1.33 to 1. Now this is current volume ratio. So you realize very similar. I found a mole ratio previously. Now I use this thing called volume ratio. The way to work it out is the same. Then in terms of equation, I want to find the volume ratio. It will be equivalent to the same as the mole ratio. Okay? It will be equivalent for the mole ratio. So how to find the volume ratio from the equation? Okay, I'm going to look at CO is to NO. It is actually 2 is to 2, which means 1 is to 1. Can? So far all okay? Thumbs up if all okay? Okay, can Now, so if I now compare, now let's compare these two, compare these two. So what you realize is that CO is 1.33 in terms of current volume ratio. Equation only needs 1. So 1 NO is supposed to react with 1.1 NO, so react with 1 CO. But my current situation, 1 NO, I got 1.33 CO present, right? So it tells you that this CO is in excess, and hence NO is the limiting reactant. Okay? It's the limiting reactant. So I know that I'm going to use volume of NO for my subsequent calculation. Okay, hence NO is the limiting reactant. Okay. Now, once I know NO is the limiting reactant, I'm going to take the volume of NO to calculate the volume of nitrogen. Because they're both gas, I can just multiply by what I call the mole ratio, which is actually also the same as the volume ratio. So can you see N2 is actually 1 in terms of the thing. NO is actually 2. So the mole ratio is actually times 1 over 2. Hence, to find the volume of N2, this is just taking 60 multiplied by half. So I'll get 30.0 dm cube of NO. Bracket 3SF. Can? Okay, yeah, so that's it. End of the stoichiometry 2. Okay, any questions? Any questions? Thumbs up if all okay. I think the rest all sleeping already. Okay. Once this worksheet is done, actually question, what else do you want me to go through or all give up already?
Wait, can you go through one final question on stoichiometry with like most of like the concepts? In like,
One question on stoichiometry.
yeah,
But don't have any more question there.
I think can like do like a summary on like everything.
yeah, can you do like one that has like most of the concepts inside. So like we know how to like link it together. Because
You're
sometimes
really
like, we ask different things, then we don't know how to use what to find what.
okay. You all understand this.
Wait.
You all understand this this kind of do you understand what I'm writing here? This flow diagram thing. Do you understand what I'm writing here?
Yeah.
You all know, right? Okay. So you realize in mole concept, right? One of the key things is always to know what are the steps to take to reach to the final answer. Okay, so it's always depending on what's being asked. Now, in general, okay, I'll just do a quick summary of the whole thing now. So it may be some of you may find this like, okay, actually I know all this, right? Then there's good. Those who do not know, then at least you can consolidate. So I'm just gonna help do a summary map for what I did for my class also. Okay. So in general, this question is called mole lah. So obviously you must start from mole in the middle, right? So mole. Now, generally to find the mole of substance, you all already know how to do. So let's start from mole. Mole converting to mass was actually the first thing you all picked up. So mole to mass, is multiplied by MR, and obviously to interconvert back is to divide by MR. Now, in this part here, when you first learned, you realize under mass, you actually covered a few things. You covered percentage by mass. You also covered empirical formula. Okay? So in terms of while doing this whole interconversion between mass and mole, you know that you need to also learn about percentage by mass and empirical formula. So that's something you need to cover lah. Okay? Next part, the teachers most probably would have gone through from mole. Then you will find number of particles. When I say number of particles, it can mean atoms, molecules, or ions. Okay? Now, to find number of particles is actually to take mole multiply by 6.02 times 10 to the power of 23. Okay? And obviously to convert back is to divide by 6.02 times 10 to the power of 23. Okay? So this number of moles, number of particles, and actually number of molecules, number of atoms, number of ions, right? This number of particles thing normally is very confusing because, for example, if I tell you, I got 3 molecules of CO2. Then my question is, how many atoms of O is inside there? Okay, the answer is 6 atoms of O lah. Okay, this is the idea of calculating the minute part of it. Now take note, these atoms I never times because if I do more, then I ask you find atoms, then you must times 6 power 23. 6 times 6.02 times 10 power 23. Okay, but in this case, I'm just comparing molecules and atoms, then there's no need to times that number. So only when mole to number of particles, then you need to times this big S number here. Otherwise, don't need. Okay, next. So this is one part. The next one, most of you are very familiar with. Okay, is from mole, you can convert to the volume of gas, which is in dm cube. So mole to this is actually multiplied by 24 dm cube. Or to interconvert back, you divide by 24 dm cube. Okay? So this was a second portion. This was another portion that you all learned to interconvert between the volume of gas and number of moles. Okay, next part that you all actually covered as well is to convert mole, which we just now also did. Mole convert to concentration. This concentration here is a mole per dm cube concentration. So mole to concentration, in this case here, I'm going to divide by the volume. And obviously, you convert back, you multiply by the volume lah. Okay? And just to wrap this part up, there's one more rectangle here. Because if I take the mass and divide by the volume, actually I can get another concentration. This concentration is a gram per dm cube concentration. Okay? Which means I can multiply by volume to get that mass. Now, based on this whole thing here, there's one last part of the arrow. Because you can see under both concentration, there's a per dm cube, right? So I can ignore the per dm cube. I just look at this. How to convert gram to mole? Gram to mole, or you can say gram per dm cube to mole per dm cube. You know that this is going to divide by MR, and to convert back, you multiply by MR. So this whole chunk of text over here, you realize it's like a cycle. Okay, it's like a cycle. You know one side, you know the other side. Okay? Now, with this part over here, This one is interconvert within one substance. So let's all of this actually is substance A. So mole of carbon dioxide to mass of carbon dioxide to number of carbon dioxide molecules to the volume of carbon dioxide, what's the concentration of carbon dioxide. So everything is all one substance. It could be the reactant only, okay, or it could be the product only kind of thing. So it's just looking at one substance. So to convert from one substance to another, all of you are very familiar with already. So to convert from the mole of a substance, let's call it mole A, to the mole of another substance B, you actually multiply by the mole ratio. Okay, so actually this is all you need to know in terms of the how to calculate by a flow chart way. Now, once you have covered all this, obviously the next part you have actually covered where the teachers go a bit more in depth was the idea of limiting plus excess reactant. Okay, so to find limiting excess reactant, or how do you know when to find the limiting or excess reactant, is that when both uh, reactants amount in terms of mole or whatever thing, okay, maybe to show you the word amount. When both reactants quantities are given and you are not sure which to start, okay, then you will need to find which is the limiting, which is excess. So to do this, you actually find the number of moles of reactant 1, you find number of moles of reactant 2. Then what you do in the next step is to compare the current versus the equation mole ratio. Okay, so that was what I've been doing to find my limiting and excess lah. Once you find limiting excess, then what you can do is take the limiting or use the limiting mole to find the products form. Okay, so actually this is the star here because why you always want to find limiting is to know which is the correct value to use to go and find how much products are formed. Okay, so that is the idea behind doing the limiting and excess reactant. And of course, the last part, once you have done all this, is once you've done all this, the last segment that we have done, which is also your teachers have covered, is the idea of percentage purity. Because your sample is not pure, that's why you find percentage purity, or you look at percentage yield. Percentage yield is about product, how much product is formed compared to what is supposed to form. So percentage purity, typically, you are calculating for reactant one. Percentage yield, normally you are calculating for the product. I'm not going to write the equation here because we wrote it at the top in terms of how to find percentage yield, how to find percentage purity already. But the key thing for this two is to really look at the equation, okay? And then find out what should be on top, what should be at the bottom. So I just want to put one, for this part here, I just want to put a star. Normally in the exam, when you are very panicky or when you do, you're like, you're just not in the right frame of mind because especially if more calculation last question, I tell you, you are stuck one. Because sometimes when you calculate, you realize, shit, how the percentage purity is more than 100%, or how the percentage yield is more than 100%. At this particular stage, if you have not enough time left to recheck your working, what you can do is you just take the two numbers that you've calculated, you swap them around. Because why? In order for it to become more than 100%, means that your numerator is bigger and your denominator is smaller. Once I flip it over, that now my denominator becomes the numerator, my numerator becomes denominator, my overall number will definitely be less than 100%. Okay, so do this. If you got not enough time left, you want to cook out some answer that you know must be less than 100%, then just swap the numerator and denominator around and you should be fine already. And okay, so that's for more in terms of like the general summary of all the things you could have covered lah. Okay. Any questions? All okay? Hey, you all still got energy to go on some more, man. I think you all no energy yet. You all want to sleep, right? 12 o'clock already, no? Right. So, should we stop for today? Yes or no? Hmm. What do you think? What else do I need to cover? Redox, you all can go and see my video lah. Just go and look at the oxidation state one, you all should be okay with it. Oxidation state and reducing oxidizing agent. Just go and see the video, you'll be fine now. Okay, I do summary, I'll just say the same thing as I said there, so no point also. Oh, anything else for me to go through? Can unmute and talk. Okay, I thought I'll stop the recording. I'll stop recording. Let's stop in case some of you very shy.